In this video, I'll walk you through the solutions for the midterm exam for 2025. Let's start at the top. And the quality is a little iffy because it's a scan of a printout. So if it looks fuzzy, it's not your eyeballs, it's the scan. All right, so number one, fundamental unit of mass in the meters, kilograms, seconds, MKS system is what? If you don't know your fundamental units, you should smack yourself. SMMACKK. Seconds, meters, moles, amperes, candela, kilogram, and Kelvin. So unit of mass is the kilogram. Choice 3. Next. Also keep in mind the fundamental unit for mass is not the gram. It is the kilogram. So just be aware of that. Unit of force. Force is measured in newtons. You should know that as well. That's choice 2. Approximate length of a baseball bat. These approximation questions usually helps if you take the power of 10 and write out the number itself. So we have 0.1, 1, 10, and 100 meters. And we're talking about a baseball bat. And with the estimation question, you can usually knock out 2 is making no sense. And so it's not 10 meters and it's not 100 meters. That makes no sense. And it's a baseball bat. So, like, come on, 1 meter. This one's not hard. So for 4 and 5, know your vectors. There are more scalars than vectors, so if you know your vectors, you know your scalars. So following Mad 5, we have that force is a vector, so 4. And displacement, momentum, and velocity are all in Mad 5, so they are not scalars. Time is, so both these guys are both choice 4. Speaking of vectors, number 6 is a vector question. If vectors are in the same direction, you add them. If they're in opposite directions, you subtract them. But if they're at right angles like this guy, you use Pythagorean theorem. We wind up with 13 newtons for this resultant, choice 4. If we look at the other answer choices, 5 and 12 in opposite directions make 7. That's the least they can make, so they can't make 5 whatsoever. And then 7 is if you subtract them, so it's either 3 or 4. But Pythagorean theorem tells me it's choice 4. For number 7, let's write down the things that they're telling us. We have a ball going at 10 meters per second, kicked at an angle of 30 degrees. And you want to know the magnitude, which means amount, of the horizontal component of the ball's initial velocity. So horizontal component, you may remember us saying that x is cosine, but that's why we say that, because the x component, the magnitude of the x component is the magnitude of the vector times the cosine of the angle. That's on page 6 of the reference tables. Make sure you're in degree mode. So when we do 10 times the cosine of 30, we get 8.7 meters per second. And so that, if we were looking at this sketch that I drew up here, that would be this component here, the horizontal component of this vector. If the magnitude of the vector is 10 meters per second, the horizontal component is 8.7 meters per second. So for number 8, they give us the distance and the time, and they want the speed. So I wrote down my distance and time, and average speed is distance over time. So 100 divided by 10 is 10 meters per second, and that's choice 2. Number 9. That V equals D over T, by the way, is on this page 6 of the reference tables. So is A equals delta V over T, and that's our equation for number 9, where they give us the initial velocity, the final velocity, and the time, and they want the acceleration. Remembering that delta always means final minus initial. Notice that initial and final are both east, so they're both positive. If V final were west, I would have to make it negative because it's the other direction. And so we do delta V over T, we get 8 minus 3 divided by 2, which is 2.5 meters per second squared, choice 1. In number 10, now notice they say at rest. So at rest, if you come to rest, the V final is 0. If you start from rest, V initial is 0. It gives us acceleration and time, and you want to know how far. So I can use D is VIT plus 1 FAT squared, which is also on page 6 of the ref tabs, to solve this problem. So for number 10, we have 0 times 12 is 1/2 times 6 times 12 squared. Don't forget the square. You get 432, but it's 2 significant figures, so it's just 430. So that's choice 3. 11, we have another start from rest, so V initial is 0. accelerates at 4.9 meters per second squared over 200 meters, and we're solving for VF. So we have VF squared is VI squared plus 2AD, another formula from page 6 of the reference tables. And the answer is not 1960. Don't forget to square root. It's VF squared. So that's 44.3 meters per second, choice 3. Now it's time for motion graphs. So a little recap on motion graphs. 3 different kinds of graphs: displacement, velocity, and acceleration. And acceleration is the slope of a velocity graph, and velocity is the slope of a displacement graph. Going the other way, displacement is the area under a velocity graph, and velocity is the area under an acceleration graph. Okay, keeping that in mind. And when you have a motion graph, the first thing you do is identify the graph. This is a d versus t graph. We know that the slope is velocity. So what is it asking? What is the motion of this body? I have a constant positive slope. So if that slope is constant and positive, the velocity is constant and positive. So we are not accelerating. The acceleration is not increasing. There is none. It's not decreasing. There is none. The speed is not increasing because we are not accelerating. The speed is constant. Choice 4. If I had increasing speed, the slope would need to be increasing, and then I would have a curve on that. Number 13. Motion graph. First thing that we do, identify the graph. So it's a V versus T graph, and it's asking about the, again, magnitude means amount. Don't get tripped by that. Magnitude, amount of acceleration. They're asking about the acceleration. Acceleration is the slope of the V versus T graph. So they're asking between 8 and 10 seconds. So we're looking from 8 to 10 seconds, and it's saying what is the acceleration of car A? Car A is the lower graph, so going from here to there, looking at the slope. So I took the slope, or I could just do delta V over T to get acceleration. In either case, I get negative 4 meters per second squared. And what are the amount of it? So the negative is not going to matter. This is going to be choice 4. Okay, so 14, another motion graph. It's a V versus T graph, and it's asking about the distance. So the distance is the area under the curve, and it says the first 4 seconds. So I'm only interested in the triangle for the first 4 seconds. So there's my triangle. I'm going to do 1/2 base times height. And so yeah, distance is the area, 1/2 base times height. 1/2 4 times 20 is 40 meters, choice 3. Okay, so number 15. Freely falling object travels downward at a constant what? So constant, we know that for something freely falling, it's speeding up. So that means it cannot have a constant velocity. Goodbye. So that means it has a constant acceleration, and it does. And the rate by which something accelerates as it freely falls is negative 9.81 meters per second squared. That's page 1 of the reference tables. All right, so that's 2. Okay, then 16. How far will a brick falling from rest fall freely in 3 seconds? Well, let's write down the givens. So we have that it starts from rest, so we know that V initial is 0, and that it falls in 3 seconds, and wants to know how far. Now, since it's freely falling, we also know the acceleration due to gravity is negative 9.81 meters per second squared. So with V initial, time, and acceleration, to solve for D, we use on page 6 of the ref tabs, D is VIT plus 1/2 AT squared. So we put everything in, and of course 0 times 3 is 0, so that goes away. And don't forget to square the time on the end. So 1/2 times negative 9.81 times 9, since 3 squared is 9, is 44 meters to 2 sig figs. So that's choice 3. All right, next. I will say this about free fall problems. Don't let them confuse you. Don't feel like you're missing information that you can't do the problem. If you feel that way, ask yourself, are you rising or falling under gravity? In which case the acceleration is negative 9.81 meters per second squared. Alrighty then. So 17, we're dealing with a projectile, so horizontal projectiles. So things that we know the velocity of the projectile is 20 meters per second. That's the initial velocity, but it's the initial x velocity. We need to keep our initial x and y velocity constant. I'm sorry, x and y velocity separate. The x velocity itself is constant. And so we write down our givens, but for projectiles, for two-dimensional motion, we have both x and y motion. So we have an initial x velocity of 20 meters per second. We have an initial y velocity of 0 because it's entirely horizontal. We know, of course, that there's no acceleration in the x direction, and the y acceleration is down towards the ground due to gravity at negative 9.81 meters per second squared. The ball falls 60 meters. I'm going to make that negative because it's falling down vertically, and that's all that we know. And we don't actually have to calculate anything. It's asking what's the horizontal velocity just before it reaches the ground. Well, the horizontal velocity, is constant because the x acceleration is 0. So if it started at 20 meters per second, it's going to continue at 20 meters per second horizontally, and that's choice 2. The total velocity will be bigger than that because it will gain vertical velocity as it falls, but it's asking you about the horizontal velocity, which is constant. Okay, so that's number 17. Then number 18, we have another projectile. This one's up at an angle, but it's pretty basic. It's asking about the acceleration for any projectile. That acceleration is downward at negative 9.81 meters per second squared. So what's true about the acceleration of any projectile? It remains the same, so that's choice 3. Okay, we have another projectile question. It says a projectile lands at the same height from where it was launched. Which initial velocity results in the greatest horizontal displacement? So it wants the biggest x displacement. And so we have different angles and different speeds. So we know that for the greatest range, I want to use 45 degrees. Because at 45 degrees, it has equal components of both x and y velocity. So I'm giving it both forward velocity to get forward speed, but the y velocity gives it time in the air. If I have a low angle, like this 30 degrees here, if I have a low angle, it gives me forward speed, but it doesn't give me time in the air, so it's going to wind up coming up short. So I don't want 30. And then be careful here. You're going to be like, oh, 45 degrees, so the answer is choice 1. There we go, 45. Well, I also have choice 3 over here, which is also 45, but has a greater speed. And so with a greater speed, it's going to have greater x and y velocity. So a greater speed and 45 degrees is going to get us the greatest range, so that is choice 3. Okay, then number 20 is our last projectile question on last year's midterm, or on the 2025 midterm. I'm recording this in 2026. And all right, so machine launches a tennis ball at 25 degrees at 14 meters per second, and it returns to the ground. Which combination of changes must produce an increase in time of flight? All right, so I want to increase my time. So if I want more time in the air, that's going to mean I want to increase my y velocity. I want more speed going up into the air. So if I want to increase the y velocity, I would want to increase my angle up towards 90 degrees. So decrease the angle, no bueno. Nope. All right, so I have 3 and 4. So I want to have more time, so I increase the angle and decrease the speed, or increase the angle and increase the speed. Increase the speed is going to give me both time and range. It's going to increase both. So I want to increase the launch angle as high as I can and increase the speed to get more time, and that's choice 4. Okay, that's it on projectiles. So from after we did projectiles, we started Newton's laws and Newton's first law of inertia. And so remember that inertia is mass. So whenever it asks about inertia, just remember that inertia is mass. Which one has the greatest inertia? Whichever one has the greatest mass, and that's choice 1. All right. 22. In equilibrium. What the heck does that mean? Well, in equilibrium means you have no net force. It says F net equals ma. If you have no net force, you have no acceleration. And if you are not accelerating, that means your velocity is going to be constant. All right, so if it says if the block is in equilibrium, the magnitude, which just means amount, don't get tripped, the amount of the acceleration is 0. And you could be like, oh, well, it's constant. It's like, well, it is constant at 0, right? There is no acceleration. It's at 0 and it stays at 0. So constant but not 0 is not the answer. The acceleration is going to be 0 if you're in equilibrium, and that is choice 1. Okay, I mentioned before Newton's second law, and so for 23 we have a net force of 25 newtons, and it's applied to a mass of 10 kilograms, and which is at rest. I guess you could say that V initial is 0. I don't know if that's going to matter. And it wants to know what is the acceleration of the block. Well, we know from kinematics that acceleration is change in velocity over time, but I don't know the velocities of the time, so that's not going to work. I also know, also on the back page of that ref tab, that Newton's second law tells me that acceleration is the net force over the mass. So if I go 25 newtons over 10 kilograms, that's going to get me 2.5 meters per second squared for my acceleration, and that's going to be choice 4 for number 23. All right, 24. So 23 is Newton's second law. 24 is Newton's third law. So tennis ball is hit with a tennis racket. So tennis racket hits a tennis ball. There's a boop force on the tennis ball. Well, tennis ball says, you know what, racket? Boop, I'm going to hit you right back, because the force is going to be equal. The force of the racket on that ball is equal to the force of the ball back on the racket in the other direction. So comparing the two forces, they are going to be the same. Choice 3. Okay, number 25. An apple weighing a newton on the surface of the earth, what is its mass? Well, we're comparing mass and weight, so... Alright, so if we have 1 newton of weight, that's going to be 1/10 of that for the mass. And so 1/10 is choice 1. Again, these are powers of 10. So whenever you see powers of 10, you might want to write them out as actual numbers. 0.1, 1, 10, or 100, we wind up with 0.1 kilograms, and that is choice 1. Okay, speaking of weight or gravitational force, we have number 26, with force times distance. So it's talking about the relationship between force and distance between a space probe and the Earth. That would be Newton's universal law of gravitation, where we see that if I increase the separation between the space probe and the Earth, it's going to decrease the force due to gravity. So it's not going to increase, so it's not going to be choice 1 showing no relationship, or choice 4 showing an increasing relationship. It's either 3 or 2. But inverse or inverse square follows this, they call it a hyperbolic curve. Inverse or inverse square looks like choice 2, not choice 3. So there you go. All right. And then similar to 26, but using the same equation, but this relationship shows that we have mass versus gravitational force, and as mass increases, gravitational force increases, which is different than gravitational force and separation, where they have an inverse or inverse square relationship. And so it says if the mass increases, gravitational force of attraction, otherwise known as its weight, increases. So that's going to be choice 2 for 27. All right, let's move on to 28. All right, so 28 is talking about a box that is moving to the right, and it says which way. So it's moving, see the velocity is going to the right, and it wants to know which way does the friction go. Friction always goes the other way. It opposes motion. And so the friction is going to be to the left, and that is choice 4. It's not always to the left. If the box were moving to the left, the friction would be to the right. It always opposes motion. Okay, 29. So this one actually has a calculation. Let's write down things that we know. We know the weight of the block. Okay, we know the weight. We know it's rubber on dry asphalt moving. We know its speed is 2 meters per second. It is a constant speed. and it wants to know what is the force needed to make that happen. So we're going to be solving for the friction force, but I want to show you why. You may remember that net is push minus friction, which is not on the reference tables, and since the velocity is constant, that means that my net force is equal to 0. So left side of the equation is 0, push minus friction, which means that push, so therefore, boop, push equals friction. And so what we're actually solving for here is what is the friction force? Solving friction force. Friction force, we know, is coefficient times the normal force. And so they told us before that rubber on dry asphalt moving, that's going to be, I'm going to look up the kinetic coefficient on page 1 of the reference tables. And I'm going to need to do rubber on dry asphalt. And we get a value of 0.67 from the reference tables. Also, we need to remember that when you're on a level surface, the weight of an object is equal to the normal force. Weight pushes down to the ground pushes back, same amount with normal force. So there you have it. So we wind up with 0.67, no units for coefficient of friction, times 60 newtons, and 0.67 is 2/3, so 2/3 of 60 is 40 newtons. So after all of that, we get choice 1 for number 29. A little bit of work in there for number 29. I mean, like, some of them are more complicated, like 29. Some of them are not, like 28. What do you want from me? Okay, so 30, talking about centripetal acceleration. So now we're into circles. And so things that we know. So for 30, they give us the mass of the car, they give us its speed and its radius, and they want the centripetal acceleration. Well, page 6 of the reference tables tells me that centripetal acceleration is speed squared over the radius. So I put in that speed of 12 meters per second. Don't forget to square it. Divide by the radius of 30 meters. And that gets me 4.8 meters per second squared. And that is choice 2. Okay. We are almost done with the multiple choice. Here we have number 31. And it gives us a bunch of information. It gives us a mass and it gives us a speed. Here, let's mark up the problem. We know the mass of the car. We know the speed of the car. We know the radius of the circle. We know a lot of stuff. But then it says, at point P, the car hits an area of ice and loses all friction force on its tires. Which way is it going to go? So that's when the car is at point P right here. I don't know if you can see that. Maybe you can change the color. There's the car right there. And so if it loses its friction, it goes in the direction of its last velocity, which is this way. When it's at that position, it goes straight forwards. And so what would that be? It would be B. Choice 2 for number 31. So yeah, they give us all this information, but they don't ask us to calculate anything. They just want to know which way is it going to go when it loses its friction. And again, it's like, what does the friction have to do with it moving in a circle? In this instance, remember that if you have car tires and you're turning in a curve, then the centripetal force is provided by friction. So if you lose that friction, you lose the centripetal force, you are no longer moving in a circle. You're going to go straight forward in the direction of your velocity. Okay, and then the last for the multiple choice are numbers 32 and 33. 32 is a circle guy, 33 is also a circle question. And so 32 wants to know, for something that's moving in a circle, which way are the centripetal force and the velocity pointing? Well, the centripetal force, the center-seeking centripetal force, center-seeking. All right, so that means the centripetal force always points towards the center. So that gets rid of choice 1, and it gets rid of choice 4 because that shows the centripetal force pointing outwards. We want inwards, so not those guys. And then the velocity is always going to be, as we saw from here, from the friction question, the velocity is always going to be forwards. And you'd be like, well, is forwards up or down? It does not matter because it's definitely not inwards. All right, so in choice 2, the centripetal force is inwards, but so is the velocity. Wah, I don't think so. Here we go. Choice 3 for number 32. All right. And then last but not least, we have a calculation. It wants to know what is the centripetal force. So let's write down the things that they tell us. So they give us the mass, the velocity, and the radius of a car traveling in a circle. And it wants to know the centripetal force, which is MAC, but AC is V squared over R. So when you throw them together, you get FC is mv squared over R. All right. Don't forget that the V is squared. Again, don't forget to square that V. We wind up with 8750 newtons for our centripetal force, and that is choice 3. Okay, so it looks like there was no momentum in the multiple choice on last year's midterm. Oh well. Also, we have 23 points of 56 for the part B, and that's because the other 33 points were the multiple choice. 33, right? So there are 33 multiple choice questions, and so most of the test is multiple choice, just like the Regents exam, and but I am at 26 minutes in this video, and so I'm going to cut this in half. This is going to be video 1 of 2 for last year's, or for the 2025 physics midterm exam. Catch you in the second video with part B.